Hi, welcome to the pre-calculus lecture series. And in this video, we're going to cover the section 6.4 is the inverse trig function and the right triangles here. And as I mentioned, this section is a very simple and easy sections here. Basically, it matched, we talk about this in the chapter 5 about the inverse function, about the, in the, like the unit circle settings here. So in here, we talk about the inverse trig functions and the triangle, right triangle settings here and how to find how to solve it. And so in here, so all the other things will follow or everything follow the same thing as we did for the, chapter 5 here. Okay, so let's take a look. But we do have a few things we need to be a little bit careful, and we're going to talk about that. Okay, so go ahead. Let's take a look at our lecture notes here. All right. So okay, so here, let's take a look here. So the way we defined the inverse function for the right triangles here, right? So let's try to take a look like what we did for our, let me see here, put a little bit higher so I can write it. All right, so now, like we did for the previous sections here, if you have a right triangle, you can move that triangle to the coordinate systems, right? So, okay, so let's try to move that triangle to the coordinate systems like this. Okay, so this is my right triangle, and this is my angle theta here, right? And so we said, then we said here, this is what? This is my y value, right? Because this is y-axis, this is x-axis, and this is x, right? Then here, what is this? The hypotenuse, right? So by Pythagoras theorem, the hypotenuse will be equal to the square roots of the what? The square roots of the x squared plus y squared, right? So we define the sine theta is just the opposite over the hypotenuse is y over r. And then in here, just like we did before, for the inverse function, in order for the inverse functions to exist, we need to have restricted domains here. So if you kind of remember what we did in the previous chapter, so what is our restricted domains here? The restricted domains has to be what? From the negative pi over 2 to the pi over 2, right? Remember that? We say that's the most important part of the inverse functions here, right? So we need to remember. Okay, so now let's do the same things here. Let's do the typical 3. And then the other ones here, this is x and y. Okay, so let's move that triangle the same ways here. So this is my right triangles, and this is my angle. So this is angle theta. So the same ways here, this is y, this is x, and this is r. So what is the cosine theta here? Cosine theta is adjacent over, right? So it's x over r. So what is the restricted domains here? The restricted domain, remember, the cosine is from the 0 to pi, right? So be very careful about this, the things here. And then the next ones here, we're going to list only 3. Of course, other 3 will follow the same way. So if you don't remember, you can go back to the previous chapter and review it. So the only thing you need to be careful is where is this restricted domains, right? Okay, so now the third one is you do the same way. You move this triangle to the coordinates, right? And this is my angle, and this is theta. And so the same way, this is y, x, and r, right? So what is the tangent theta here? It's the opposite over adjacent, right? Okay, so then be careful, the restricted here is negative pi over 2 to the pi over 2. I don't have equal sign because the tangent is not defined in here, right? So like we said, remaining 3, they do the same way. You just move the triangle to the coordinates, and then whatever you did for chapter 5, it will going to work. See here. So solving the angle of the right triangle by using this relation. So basically, what we try to do see here is we can use the trig definition to find the missing side or missing angle of the triangles, right? Of the right triangle. Let's take a look at what I mean here. So let's take a look at the first one. It said find the angle theta in the triangles here. Okay, so I'm looking for is this angle theta here, right? So the angle theta, so in here, this is what? This is the opposite side for face this theta. And what is this one? This is the hypotenuse, right? Okay, so if now I know the sine theta, right? So the sine theta is equal to the opposite over hypotenuse. So it's 10 over what? 10 over 5, 50. So this is 1/5 here. So in order to find the theta, remember so you can take the sine inverse 1/5. So we call this arcsines, right? And then if you can set the, like we said, you can set your calculator either to degrees or radians, right? So in the chapter 5, we practice on the rate. If you have the set in the radians, and then the arcsine will give you some angles here. So if you set in the degrees, you put it into your calculator, it will give you something, say it's 11.5 degrees. That means the angle theta. So because the arcsine, right? So this is arcsine giving me theta. So I know the theta here is very close to the 11.5 degrees here. Okay. Okay, now let's take a look at the other one. Like I said, this one here is very similar like what we learned before. A 40-feet ladder leaning against a building. If the base of the ladder is 6 feet, and what is the angle formed by the ladders and the building? So that means according to this picture, we are looking for this angles here, right? So this is the same things here. So this angle, so I know that this side, I know this side, right? So this angle is face this side. So what is this side is? This is the opposite side. And what is this ladder? Ladder really is, if you take a look, this is kind of like a right triangles, right? So the ladder is what? Is the hypotenuse, right? So now I can say sine theta is equal to what? It's 6 over what? It's 6 over 6 over 40. So now you can say it's 3 over like a 20 here. So what is the angle theta? Theta will just, if you take the arcsine 3 over 20, then your calculator will give you something very close to the 8.6 degrees here. Okay, so you use the inverse functions, trig inverse function to find what is the missing side or missing angles here, right? Okay, so now the next thing here, we're going to talk about how do I evaluating the expressing involving inverse trig functions here. All right, so basically we are trying to find something like this, right? So here, like if I want to find the cosine, the arcsine negative x here. Okay, so I'm going to use step by step and try to write down these formulas here. Not a formula, the direction here. So like in here, we have a cosine, arcsine, negative 5/3. First, for try to do this type of problem, you draw a right triangle. Okay, so now you draw right triangle. So here, and mark your angle theta. Okay, so I said, okay, I'm going to mark this is the angle theta. Okay, and then now write out the sides given by the inverse functions, right? Okay, so in here, okay, so take a look at here. This is what this was, so sine, arcsine 3/5. So what means arcsine 3/5? That means sine theta is equal to 3/5 here, okay? And I know the sine is equal to the opposite over hypotenuse. So the second step, they say, write that out. So I know if that's why we mark the angle. This is I mark the angles, right? So in here it said arcsine, right, is 3/5. That means sine theta equal to 3/5. So the opposite side is the 3/5, right? So this is 3. Then hypotenuse is 5, right? Because this is right triangle. So here, okay. Then the next thing's here. So use the what? The Pythagoreans, right? Use the Pythagorean to find the missing side. Okay. So now I know this side is missing. It was not given. So by this side is the Pythagorean series 25 minus what? Minus 9, right? So this side is 2016. So this is 4. So I know this side here is 4 here. Okay. Now in here, so I know, so you can rewrite this one here. So this will be equal to the cosine what? Cosine theta. Okay. Then we said find the trig value based on the definitions, right? So now I have a cosine theta. So cosine is what? Is adjacent over hypotenuse. So what is the answers here? Is 4/5 here. Okay. Okay, now let's take a look here. Example number 4, see here. This part is very important because you're going to use a lot of those things in the calculus, see here, okay? They said write out the sine arccosine x and the tangent arccosine x and algebraic expression for x. X is between the 1 and the -1 here. So the first we say that try to write okay. So let's try to write a right triangles here. Okay. So this is maybe let me try to get rid of these things, and then we can start from the beginning to work on that. Okay, so let's try to follow my steps here. Say draw a right triangle. So we draw a right triangle. All right. Then it says mark the angle. Okay, so I mark the angles here. So I will say this is the angle theta, right? Okay, so mark the angles here. Then we will write out, so take a look at the step here, write out the side given by the inverse functions, right? So this is my inverse functions, right? Okay, so let's take a look at what's that mean. Okay, so that means the cosine, arccosine x. What's that mean? That's we give an angle. And then that's basically, that means cosine theta is equal to x, correct? Okay, so the cosine, right? So based on my definition, cosine is adjacent over hypotenuse, right? So right now, my cosine x only have an x here. So which one is adjacent, which one is hypotenuse? I said, well, I can rewrite this. X is equal to what? X over what? X over 1, right? So now I know that's why here is, hey, the X has to be between 1 and -1. So I say it's X over 1. So where is 1 here? The hypotenuse here is 1. So where is the x? X is here, right? So that is my write out. Then the next thing, let's say, is use the Pythagorean to find the missing side. Okay, so this is my missing side. So this side will be the 1 square minus what? 1 square minus x squared. So it will just be 1 minus x squared. So what is that? What is this side means? 1 minus x squared, right? Okay, so now let's take a look. So finally, I'm looking for the sine, arc cosine axis here. So remember, so arc cosine is theta, so it's sine theta. So what is the sine? Is opposite over hypotenuse. So it's 1 over x squared over 1, right? That is the opposite over hypotenuse. So what is the answers here? Will just be 1 minus x squared, right? So that will be the answer. Okay, now let's take a look at the tangent, arc cosine axis here. So the same thing, that means the tangent theta, right? So the tangent I know is sine theta over what? Cosine theta. Okay, so sine theta we just did, right? So sine theta is what? Is the 1 over x squared. Then cosine theta we just find here also, so it's x. So tangent will be the 1 minus x squared over x here, okay? So that's it for this section. Like I mentioned, all the other, like when we did chapter 5, the most difficult part is this restricted domains, right? And then when you change back, how do we do the restricted domain? So here, the restricted domain is remaining the same, right? So you can change this from negative 90 to positive 90, 0 to 180, all right? So that's why everything follows the same. And the only things here is try to, how to use the inverse trig to find the missing side of the right triangles here. So that's what the little procedures we can follow here, all right? All right, that's it. It's very, very simple sections here. And that's it. This is what we're all going to cover for the chapter 6. And the next video, we're going to start a new chapter, is chapter 7. All right, it's very nice to talk to you and looking forward to start chapter 7. Have a good day, okay? Bye-bye.